Welcome to the unit rates entry into our math notebooks, FJA students. Today, I'd like you to start off, pause the video here, make sure you have all of these notes written down. So unit rates, your I can statement, which is determine the unit rate associated with ratios of fractions measured in like or different terms, and then the benefits of finding unit rates, which is finding a better price or finding distance per gallon, very useful in life. So you're gonna need to do that. You're gonna need this piece of paper as well, scissors, glue, and of course a pencil, something to write with. So we're gonna start with cutting out on the dotted lines. Notice this little slip here is actually gonna be separated. Let's start by gluing this side down right here. So glue goes right here. Then actually, maybe even before you glue, you might want to fold along these solid lines right here. This is going to kind of make a book. And then glue this side down. So it says unit rates face up like that. Take this slip of paper and you're going to glue it right here. So for our first entry, we're going to read this problem and then we're going to kind of work it out and find the unit rate. So Jennifer can read half of a 500-page book every 2.5 days. If she continues at this rate, how many days would it take her to read 3 books that are 500 pages? Okay, so half of a 500-page book every 2.5 days. Okay, well that means to me, I would translate that as she can read 250 pages, that's half of a 500-page book, every 2.5 days. So 250 pages every 2.5 days. So the question then becomes the unit rate. How do we get the unit rate? How do we know how many pages can she read in one day? Well, I can make a little diagram down at the bottom here to kind of demonstrate how I might figure that out. So I'm going to draw a box here. So I've got 250 pages total. And I know that this takes 2.5 days. So let's divide this up into, now I've got 2.5 days. Well, that makes me think one day she does 100, the next day she does 100, and the next day she does 50. And that total is 2.5 days. So each of these is a day. 2.5 days, 250 pages. Cool. So you know that because half of 500, we know this because half of 500 is 250. Oh, there it is. Sorry, I kind of cut out there. Half of 500 is 250. So make sure that's in your notebook. All right, so enter this chart into your notebook. So we've got pages and days, 100, 200, 250, 500, 1,000, 1,500, and 2,000. Well, so far, what we know is that she does 250 pages every 2.5 days. So right here, this is 2.5, and this is our known rate. For this problem, that's our known rate right there. That's the rate that we know. But we also figured out down here that means that she reads in one day, she reads 100 pages, which must mean that in 2 days, she reads 200 pages, right? Well, and if it takes her 2.5 days to read 250, how many days do you think it's going to take her to read 500? Well, that's twice as much. 2.5 times 2 is 5. Okay, and then we double that, so this is going to be 10. It's going to be 15 days for another 500 pages. So every 500 pages takes 5 days. And then another 500 pages to get to 2,000 is 20 days. 20 days. This is what we'll write down. Each day, Jennifer will read 100 pages. She wants to read 1,500 pages at a 1 to 100 ratio. So 1 day to 100 pages rate. She will need 15 days. And so that's why it's really helpful to know unit rates. We're going to do the rest. We're going to do 2 more examples. So fold this up, flip the page, and we are going to now use these two pieces of paper, glue them on here, one at the top and one kind of right there. All right, to figure out this first problem, let's read it aloud. Maddie consistently swims a quarter or 1/4 of a 200-meter freestyle in 45 seconds. If she continues at this pace, how long would it take her to swim a full 200-meter freestyle? Funny, there's a typo. It says sim instead of swim. Well, let's write down what we know. We know that she does 1/4 of 200 meters, m, in 45 seconds. Okay, well, what's 1/4 of 200? Well, that means 200 divided by 4. Well, that means she does 50 meters in 45 seconds. Okay, well, then maybe we can double this here. Then if she has 90 seconds, that doubles that. That means she does 100 meters in 90 seconds. Okay, so if we double that again, then we'd get to our 200-meter freestyle. So if 200 meters, that doubles. So then what's double of 90? That is 180 seconds. 180 seconds. So we know that Maddie can swim. It's going to take 200 meters in 3 minutes. Because 180 seconds, of course, is 3 minutes. So for our next problem, Farmer John can plant 3/8 of a row of crops in 1/8 of his regular workday. If Farmer John works for 8 hours a day, how many days will it take him to completely plant 12 rows of crops? Well, let's work it out. So we know that he can plant 3/8 of a row. So we'll write this, 3/8 of a row in 1/8 of his regular workday. And he works 8 hours a day. He works 8 hours a day. So 3/8 of a row in 1/8 of 8 hours. Well, that's a good way to get our unit rate. Well, what's 1/8 of 8 hours? Well, that's just 1 hour. So he does 3/8 of a row in 1 hour. And that's great. This right here is our unit rate. We already found it. 3/8 of a row in an hour. So let's think about it this way. Draw a line for me here. All right. So in 1 hour of his day, he does 3/8 of a row. Second hour, he does another 3/8 of a row. Third hour, 3/8. So this tells me in 8 hours, he's going to do 3/8 times 8 over 1, times 8, right? Times 8 over 1. Well, that's going to be 24/8, which simplifies down to 3. So in one day, he can do 3 rows. So in one full day, he does 3 rows. Excellent. Okay. Well, now we want to know, how long will it take him to completely plant 12 rows of crops? Well, if it takes 1 day for 3 rows, that means in 2 days he'll do 6, 3 days he'll do 9, and in 4 days he will do 12. So 12 rows in 4 days. And we can also set up our proportions. So we know that it's 1 day for every 3 rows. And that equals a proportion here, 12 rows. And to solve, what we would do is we multiply. We know to get from here to here, we would need to multiply by 4, right? 3 to 12 is multiplied by 4. And from here to here, we also multiply by 4. So x, our variable, x, equals 4 days.